All right, so in yesterday's lesson, we talked about probability distributions and how it could be a normal distribution, and the total area under the curve was equal to 1, which is our total probabilities. And we saw that curve with a mean in the middle, and then we added and subtracted standard deviations on to get those other values that you saw on the curve. And then we estimated standard deviations based on inflection points. So this is similar. This is just kind of one step away from that. We're going to just look at a standard normal distribution. And instead of it being probabilities underneath, it's how our data itself is distributed. So this one could be 1 standard deviation to the right or 2 standard deviations to the right. We're going to call how many standard deviations we are away our z-scores. Remember, we did a little bit with z-scores at the very end of chapter 2. We took an x value and changed it into a z-score. So now we're going to start using those a lot. What you need to know about z-scores, and those are going to be on our chart in a second we're going to look at. If we have a z-score of 0, that means 50% of our data is to the left and to the right, because that represents our mean. If we have a z-score at like negative 3.49, so that's like down here somewhere, we're going to say essentially past that to the left of that is 0% of the data. It's very, very close to 0, so we start rounding. Now remember, we never actually touch this axis. It's kind of like an asymptote we're approaching, but we're going to say if it's 3.5 or below, you've got a 0% of the data to the left of it. Or 3.5 above, there's 0% of the data to the right of it. We also say if you're between negative 3.5 and positive 3.5, that there's a total area of that 1 in between. And we're going to see that reflected in our Z chart in a second. Okay. So on your table, and mine's pink, but you guys have yours on the back of the packet, there's 2 pages to this. There's one page that says you're looking for the standard normal distribution, and it's a bunch of Z values. One of them has positive Z values, and the other side has negative Z values. Okay, so when we're talking about positive Z values, it means we're going to be on the right of that standard normal curve. If we have a negative Z value, we're on the left of that standard normal curve. What this chart tells you is based on your Z value, what percent of the data is to the left of that Z value. Okay, so let me pick one that's on here. Let's pick like 2.0. Okay, so find your positive Z-scores. On the left side, find 2.0, and then along the top, that's your next decimal place. So 2.00 is what we're looking for. We can find 2.01 or 2.02. So it's going to give you everything to the nearest hundredth on this chart, which is nice. So if you find 2.00, you should then see 0.9772 on your chart. Everybody find that okay? So that means, go back to that picture we had a second ago, that if I have a Z-score of 2, that to the left of that Z-score is 97.72% of the data. Okay, so it's always giving me, based on where that Z-score is, my percent that's to the left, no matter what side I'm on here. Okay, so we can use these scores to find, what's to the left, what's to the right, and then what's between Z values. So that's what we're going to practice doing today. Okay, so the next one that's up there, and I've got a little picture there for you, it says find the cumulative area that corresponds to a Z-score of 1.15. So when they say cumulative area, they're saying from the left all the way up to your Z-score, okay? So find 1.15 and make sure you can locate 0.8749 on here, okay? So you're on your positive side of your Z-scores. You're looking at 1.1 on the side, 5 on the top, go over and make sure you can locate that number, 0.8749. Everybody get that okay? All right, so let's do the next one. Let's find the cumulative area, which means area to the left, for a Z-score of negative 0.24. Okay, so you're on your negative side now. So you're going to flip your paper over. Negative 0.24. You're going to find negative 0.2 on the side, and then go over to 4, And let's see what that gives me. What does that give me? 2.4052. Sound good? You guys have to help my old eyes on here. 0.4052. Okay. Negative 2.19. Okay, so you're going to find negative 2.1 and then go over to find your last decimal place. 9 is the first column. You should see 0.0143. Okay. And then 2.375. Now, this guy has a couple extra decimal places. So what we're going to do is we're going to look at what's below it and what's above it. So we're going to find 2.37 and 2.38. We're going to find those values, and then we're going to find the midpoint or average them to figure out what's in between the two. All right, so positive 2.37. On your positive side of your chart, find 2.3 and go over to 7 and then go over to 8. So let's see what we get. 2.37 is 0.9911. 2.38 is 0.9913. And 2.375 is right in the middle of those. So the cumulative area that I'm looking for, or the percent of the data that is below 2.375, is in the middle of those, which this one you can probably do mental math, and you can see the answer is going to be 0.9912. If the numbers are a little bit further apart from each other, or it's not obvious what the midpoint is, just add them up and divide by 2. Just find the average. Okay? All right. So let's do one with the calculator. Hopefully my calculator works a little bit better than yesterday. Let's see here. You guys have your graphing calculator. We're going to go into that distribution menu again that we saw, which is under our VARs menu. Okay. And yesterday when we made the graph, we looked at the normal PDF. Today we're going to do normal CDF. Okay. And then you can type in what you're looking for. So the first thing I'm going to do is type in a very, very low number. So negative 10,000 is going to be like really, 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 really far to the left. That's a z-score that we're giving. Okay, so we just want to make sure it's really far down so it accounts for everything that's on the left. So negative 10,000, you could really use like negative 1,000. You don't have to change that as you do this from one problem to the next. Then you're going to pick a z-score. So in this example, the z-score that we're trying to find the cumulative area to get to is 1.15. And then you're going to tell it what your probabilities are going to range between, which are always going to be between 0 and 1 for our purposes. So 0 and 1. And then that is the cumulative area. Okay, so the area leading up to 1.15, and you can find it on your chart if you want to confirm, is going to be 0.8749. So that's the area to the left of that z-score. Okay, so everything is going to remain the same except that second value. You're going to change the z-score. So you're going to hit second, and then the VARs button, and then it's the second choice, normal CDF. Okay. Are you doing it on your screen there? Is it working? Yeah. You guys have this graphing calculator on your computers. I forgot those were on there. The icon looks like this. It's TI Smart View. If you want to play with it, you can. Isn't technology wonderful? Okay, so try it with negative 0.24. So try it with the calculator and then check it with your sheet. Okay, so everything's going to stay the same except for that second value when you type it in. and the bottom one's the one we did already, I guess. All right, so you should get about 0.4052 for the negative 0.24, if you want to try it. The 1.15 is the one we just did a second ago up here. Nice thing about the calculator is it gives us a few more decimal places than the chart does, if you were going to actually use this for statistical research or calculations. All right, so if you have a z-score that is negative, your z-score is somewhere on the left side of this curve. You should expect that your answer is 0.5 or less, because we know if we're at the mean, it's 0.5 to get to it. So anything smaller than that is going to be smaller than 0.5. If you have a z-score that's positive, you know it's going to be greater than 0.5 because we're to the right of the mean. So that's just something you can kind of double check that you're doing it correctly. If it's negative, you're going to get a small number. If it's positive, you're going to get a little bit bigger number. All right, any questions with the calculator? Okay. So now, let's say we're going to sketch this and we're going to find it on our sheet. We're going to find the area under the normal curve that's to the left of a z-score of negative 0.99. Okay, so remember your z-score of 1 or of 0 is right in the middle. Okay, and then you can estimate those standard deviations, like those inflection points that we talked about yesterday, right? That's going to be 1 standard deviation in either direction, approximately. So negative 0.99 is really close to a z-score of negative 1. It's just slightly to the right of it. So maybe right about there. Okay, so that's a z-score of negative 0.99. And we're finding the area to the left of it. Okay, so I can already tell you my answer is going to be smaller than 0.5 because it's to the left of the mean. And now you can use your chart to find it. So find negative 0.99, and you guys should see your answer is 0.1611. Okay. Let's say I want to find the area under the curve that's to the right of 1.06. Okay, so do your best again to sketch this. We know 0 is in the middle. We know 1 would be where my inflection point is to the right. 1.06 is just going to be a little bit higher than that. Like right there, okay? Rough sketch. This time we're finding the area to the right. Okay, so normally when I have a z-score bigger than 1, what I'm going to get off my chart is going to be something bigger than 0.5. But you can see based on what I've shaded here, it's less than half of the curve. So we should expect a number smaller than half. So here's how we use the chart to figure it out. All the chart is going to give us when I look up 1.06 is the area to the left. So let's go ahead and do that first. Area to the left, 1.06 is 0.8554. Okay, so that 0.8554 is everything in white there. So what do you think I'm going to do to get the area shaded in red? The total area under the curve is 1. So all we're doing is finding a complement here. 1 minus. And you can use your calculator for that. So what does it give me? 0.1446. Okay. Let's say I want to find the area under the curve between a z-value of negative 1.5 and a z-value of 1.25. Okay, so again, let's sketch it first. So negative 1.5, maybe over here somewhere. And 1.25, maybe over here somewhere. And we're finding the area between them. Okay. All the chart's going to give us is the area to the left of each. So let's go ahead and do that. The area to the left, I'm going to start with 1.25. Positive 1.2, go over to 5 on your chart, you get 0.8944. Okay. A z-score of negative 1.5. So find on the negative side of your chart, you're looking for negative 1.50, which gives me 0.0668. Okay. So 0.8944 is from the 1.25 to the left. 0.0668 is from the negative 1.5 to the left. I'm trying to find the area in blue. So what can I do with these numbers? You don't need to do 1 minus. Actually, it's maybe going to be easier than that. So if I have this, the 1.25 to the left, right? But I don't want this part in white on the left side. So if I don't want this part in white on the left side, what can I do? Yeah, just subtract them. If you take the larger one, which is from 1.25 all the way down, and subtract the smaller one, which is the negative 1.25, you're left with what's in the middle. So that's why I ordered it this way. You're going to do your larger one minus your smaller one to get an area in between. So subtract. Can somebody tell me what that is? 0.8276. All right, so bigger minus smaller. Good? Okay. You guys try these 3. And I think that'll wrap it up for us today. Correct answers. So just make sure you look for your keywords, right, left, between. So to the right, you're doing a complement of what you find. To the left, just using the value straight off your chart. And between, you have to subtract the bigger one minus the smaller one, or the one to the right minus the one to the left. Part C, a little tricky. You've got to first find a z-score of negative 2.16 and negative 2.17 and find the middle of those, which I think it was 0.50 and 0.54. So I just did that one mental math. And then again, just bigger minus smaller. So remember, what we're getting here is essentially the percent of the data that is in that region. So make sure that what you're shading matches what you see as an answer here. I've shaded about 98% of this chart. So that makes sense with what I'm getting there. I shaded about 7% of it here. Okay, so if I got this shading, but my answer was like 0.56, that's a problem. They don't match up. So you either need to check how you graphed it, or you need to check how you found the value of it. Okay. What questions do we have on here? Okay, so your 5-1 Math Excel is due tomorrow night. So you guys have the rest of the period today to work on that. They're mostly quick little problems like these ones. Tomorrow I am not going to be here. So we have section 5.2 on the calendar. 5.2 is nothing new. It's just putting 2 things you already know together. So you're going to be using this chart a little bit with probabilities. And then we're also going to use the formula that we used for a z-score back in chapter 2, where you do x minus the mean divided by the standard deviation to find the z-score, and then you're going to find it on your chart. So the 2 things you already know, it's just putting it together. The video you're going to watch is, I think, like 13 minutes. That's it. Super short. So I linked it on the WAG. You can watch it tonight if you want to, or you can do it in class tomorrow. Mr. Leff is going to be your sub tomorrow. He's everybody's favorite. And so tomorrow is yours to decide how you want to do it. Just before you come back to class on Monday, you need to make sure that the 5.2 13-minute video is watched, and then you can use the rest of the time in class tomorrow just to work on homework or whatever. Okay. All right. Your 5.2 Math Excel is going to be due on Tuesday night, so you guys will still have Monday to ask me questions if anything's not clear tomorrow. All right. Good. Sweet. Sweet. Great. Awesome. Thank you. I'll do cell phone lotto.